Let's take a look at this limit. The limit as x goes to 0 of tangent of 3x minus x, whole thing divided by arc sine of 3x. Before we get started, let's confirm that this indeed has the requisite form for L'Hopital's rule. If I plug in 0, tangent of 0 is 0, minus 0, and the arc sine of 0 is also 0. So this has the form 0 over 0, and so L'Hopital's rule applies. So the limit as x approaches 0 of tangent of 3x minus x divided by the arc sine of 3x. Okay, so I take the derivative of both the top and the bottom. On top, we get secant squared of 3x times the derivative of the inside, which is 3, minus 1, all over. All right, on the bottom, derivative of arc sine is 1 over square root of 1 minus 3x quantity squared times the derivative of the inside, which is 3. Okay, now that looks like a mess, and that's because it is a mess, but as x goes to 0, this no longer has the form of L'Hopital's rule. So this, if I can now just plug in 0 directly, and it's okay. 3 times the secant of 0. Secant of 0 is equal to 1. So 3 times 1 squared minus 1 over. If I plug in 0 into this, I get 1 over the square root of 1 times 3. And so that simplifies to 2/3. And so this limit is equal to 2/3. Now, again, this can be visually confirmed by looking at the graph. So if you graph this function, tangent of 3x minus x over arc sine of 3x, it looks something like this if you plot that on your calculator. And it looks plausible that the answer is 2/3, somewhere between 0.6 and 0.8. So it looks plausible that the answer is indeed 2/3. Looking at the graph gives a visual confirmation. However, the full credit for the problem, you need to use L'Hopital's rule.